All right, I think we're ready to go. So Google Meet's having some technical difficulties today. If people are having issues, let me know in the messages, but otherwise we'll get started. So Solana Foundation Validator discussion, June 12th, 2025. Welcome everyone. On the agenda today, we're going to have some validator updates, some pretty important validator updates today, so pay attention. There will be a mainnet release out hopefully soon. I'm going to encourage everyone to adopt it as soon as possible. So updates first. I'm going to introduce Brian Wong from Anza. He's the new Dev Rel Lead from Anza. So he'll have a minute to introduce himself and answer some questions. And then I think the majority of the call will have time to talk about Alpenglow. So Kobe from the Alpenglow or the Anza research team is here, and I believe Quentin as well. They're going to talk in a little bit more detail about Alpenglow and answer some questions. And then, yeah, have time for Q&A. So diving in. First off, 225 or 2215 is recommended for mainnet on Agave, and FireDancer 0.504 is recommended for mainnet as well. With the caveat that both these will see, both Agave and FireDancer will see new releases hopefully today that will have an important feature activation that we'd like to activate as soon as possible. So as soon as those come out, you'll see the announcement. Look out for them today. Please upgrade as soon as you can. Yeah, any questions about that? Nope. Cool. All right. Should be out shortly. Again, announcements should be out as soon as it's ready. Another thing to note, Agave and Jito, once they go to version 3.0, next major release, will no longer have pre-built binaries. I think for a lot, this is not a big change, but if you do rely on the pre-built binaries, be ready to start building from source. 2.3 is going to testnet soon, and then the next release will be 3.0. Agave, or sorry, I should say Anza is also targeting quicker release cycles. So 3.0 could be on testnet as soon as 10 weeks from now. But that's obviously pending everything going well. So if there's any issues, any things that slow that process down, it might be longer than 10 weeks. But just to give you a timeline, 10 weeks from now, 3.0 on testnet, we're probably looking at 3.0 going to mainnet within 20 weeks, most likely. So be on the lookout for that. Another thing to mention, 2.2 is out there. It's now over 95% on mainnet. So thank you everyone for upgrading. I know upgrading right before Accelerate was not easy for some, but appreciate the work. We have feature activations ongoing now for 2.2. The next up in the queue is the accounts lattice hash. Because of the feature activation I mentioned earlier, that's going to be delayed a little bit, but hopefully that will restart next week. So yeah, accounts lattice hash should be a pretty big performance improvement for the cluster. Also coming in 2.2, the CU limits are going to be raised to 60 million CUs. So two big changes coming within the next 6 or 7 weeks. Any questions on those updates? No. Okay, yeah, like I mentioned, the most important one is this release coming out shortly, so look out for that. Oh yeah, one more update that I didn't mention. So Gossip also got a big improvement. In 2.2, there were a big reduction in Gossip messages, which resulted in a huge reduction in ingress. Greg has a tweet about it, but if you haven't seen it yet, I believe it's here. You can see this big drop in Gossip traffic. The pronounced drop happened when 2.2 feature activations started on the cluster. So the feature activation wasn't directly related to Gossip, but there was still 2.1 nodes in Gossip that were sending a lot of messages. Once the 2.2 feature activations happened, all those 2.1 nodes got flipped off, and now it's only 2.2 nodes that are sending much less traffic in Gossip. So great to see that. And shout out to the networking team for big improvements to bandwidth. Testnet, 2.2.15 is also recommended for testnet and fire dancer 504. 2.3 would be or will be out shortly. So if you're operating on testnet, look out for that. Probably within, depending on the other release, probably happening this week or next.
Hopefully today.
Hopefully today. Thank you, Steve.
Although we're going to run it for a bit before we have other people run it. Try to hit all the obvious hurdles ourselves.
Cool. Yeah, a question also from the networking team. So there's a set of startup ARGs that they'd like to deprecate and want to get feedback from the community on if people are using these, and if so, what the use cases are. Essentially, the idea is to eliminate nets and the use of that in the client in order to do multi-homing. So this is the idea that you could have multiple IP addresses, multiple connections for your validator. I think Alex talked about that in the last core dev sync. So anybody who uses any of these startup ARGs. Specifically the gossip host one, is there anyone that uses that for any reason? Interesting. Yeah, can you expand a little bit on what you use the RPC bind address for? Yeah.
Yeah, I don't know. I guess I set it to 0000, which I think is binding to all interfaces, because I think I want to access it locally and remotely, but maybe that's the default. Maybe I don't need to set it.
Yeah, I have to admit, I also have done that in the past, and I don't fully know why. So I mentioned that to Alex. Maybe if Alex is on, you can.
There isn't any benefit to setting it to 000. There would be
Okay.
some case for setting it to a valid external address if you're behind the NAT, or to localhost if you want to restrict it to local loopback. But other than that, like if you're setting it to all zeros, you can just as well skip it.
Okay, great. Yeah, so it sounds like that one, if you're only just setting it to localhost or 000, you can deprecate that. But yeah, if anyone else has any use cases for these, let me know. I'll follow up and be planning most likely as well. Any more thoughts, questions there? All right, moving on. Okay, yeah, so now I want to introduce Brian. Brian is the new Dev Rel at Anza. You can find him on Twitter at 0xbrw, and I believe the same name on Discord. Brian should be on the call if you want to introduce yourself.
Yeah. Hi, everyone. Yeah, I'm Brian. I'm the new Dev Rel that joined Anza. Prior to this, I did some Dev Rel at Aptos. So I actually had the role that I think Mert called out like a while back. He saw a job description where Aptos was looking for a Dev Rel that was going to target Solana projects to try and convince them to come to the Move ecosystem. Didn't end up working too well. I mean, Solana was very strong, a lot of network effects. But yeah, before that, spent some time in big tech as a software engineer. So yeah, just joined, I think, starting my 4th week. My 1st week was at Accelerate, so I might have met a few of you. And yeah, mainly, I think some initiatives that we want to work on at Anza as a Dev Rel is mostly, telling the story of the Anza engineers. Seems like, a lot of them work on really impressive stuff, but in terms of comms, it's like a bit lacking. A lot of our things are like, hidden through, GitHub folders or through pull requests. So trying to pull out that information and making it more discoverable is something that I want to do. And yeah, another comment that I always see when I introduce myself as the Dev Rel, it's somehow it always gets mentioned that there was someone before me that came that, wasn't very present. So hopefully aiming to, be more available. You can reach me on Twitter, Telegram. I'm also on Discord, so I check every message. So if anything you want to chat or talk about offline, like I'll make sure to take a look.
Any questions for Brian? Now's your chance to gain your thoughts about what Anza should be doing Dev Rel wise.
Quick question, Brian, just out of curiosity, where are you located physically?
I'm in California right now, Southern California, but I'll be moving to New York. So I'll be in the New York office. Oh, you're on mute.
Yeah, I had my audio off also because there was a feedback. So if you could repeat, thanks.
Oh yeah, so I'm based in California right now. So I'll be moving to the New York office.
Cool. Anyone else? All right. Well, welcome, Brian. And yeah, reach out to him on Twitter, on Discord, 0xbrw. I also put it in the in the chat. All right. Moving on. So I'm sure a lot of you have either saw the presentation at Accelerate or seen the news since. But Alpenglow is the new proposed consensus algorithm for Solana. And we have the research team here that created this algorithm. So they're going to talk a bit about, I think, a little bit more detail about what Alpenglow is and answer questions. So I think Toby and Quentin, if you want to take it away, I can stop sharing screen.
Hello, hello. Can you hear me?
Yep, we can hear you.
Yep.
All right, let me share my screen. Mm-hmm. It tells me to quit and reopen Chrome. Okay, so I'll be back in a moment.
Yeah, sorry, you have to restart. Any other Alpenglow or otherwise thoughts before he comes back? Hi, group today. Yeah, they should be able to join. It's just really slow. So if you're having trouble getting in, let them know. Just wait. I'm not sure. I think it's something wrong with Google Meets today. Yeah, that's a good question. I'll let either Quentin or Kobe answer that, Zan.
Yeah, sure. I'm not sure I get the question entirely, but I mean, for the most part, we are not taking anything away from the old protocol. Like we are not just dropping things from the old protocol or something. We built the protocol mostly from scratch based on the proof of history, you mean? Okay, yeah, proof of history we are dropping indeed, yeah. But it basically serves the purpose of a clock for the most part, and we really just replace it with a clock in the new algorithm.
Okay, but presumably
Like,
it's still than a clock.
and-
It's like it's a clock that guarantees, at least at the limits of computational efficiency in SHA hashes, that that there's minimum time between events. And how do you guarantee that when you're just allowing validators to sort of all agree on the clocks? If there's a drift and some subset of validators drifts away from others, does that cause a problem? Are there potential for those to lead to instances to lead to security exploits along the seams of time of the clocks?
I mean,
And throw it away. I just don't understand.
Yeah. Yeah, I mean, one answer to this is safety is not a problem anyways, because the protocol is even safe in asynchrony. So even if all the clocks break and everything shifts, the worst thing we can do is we lose liveness. And then for liveness to fail, we would have to have like a small drift in clocks is also not a problem because clocks resynchronize all the time. Like we only need to measure like local elapsed time for short periods. Like we need to measure, okay, from the last certificate that we all received, we measure how long should it take until we see the next block, for example.
But if the local clock diverges from the cluster, then there's an opportunity for your local clock to be sort of fooled. Someone can come along as a future leader and emit blocks in an earlier slot in order to, I don't know, censor, other leaders. And depending on how far your clock has drifted, you may not notice or, have any way of detecting this. You can't, if you get two competing leader blocks, how do you detect which one is the quote unquote right one?
Yes. But the main thing is that it's a threshold clock. Like a threshold of stake needs to agree that this is the time and then vote on the block accordingly. Like if just your clock, if you are one guy and your clock runs 10 times as fast as everyone else's, then the only thing that will happen is your votes are wrong. Like you will vote skip when you should vote notarize or the other way around. But you will not suddenly think a block is finalized or something and accept this block as the block that is in the chain. For this, a vast majority would need to run at the wrong speed, but at that point it would kind of be the right speed, at least for the network.
So that, I guess what you're saying is that was already true. Proof of history kind of didn't accomplish anything because it was already a case that validators had to individually decide when they saw two leader blocks competing which one to vote on, and they would ostensibly could already have done that just by like deciding that the later leader must have come too early, or that they're so far outside the bounds of expected time when their leader blocks are due to arrive that you just won't vote on that one. So you're saying that proof of history kind of already didn't accomplish anything because it was already a consensus-based mechanism for deciding when to vote and which leader slot to vote on.
I mean, I'm not sure if that was the case in the old protocol necessarily, but it's definitely a problem that can be solved without this cryptographic mechanism and can be solved purely based on the voting. And that's how we do it in Alpenglow, and that's how most protocols do it also. So it's not a necessary part of the old protocol.
I guess it does introduce some sense of like external dependency because all of us get our time probably from some external source. So the external source of time is now, I don't know if it's an attack vector or if it's just a potential for unreliability within the network or for a particular validator. You kind of have to get the right time. Whereas with proof of history, I guess, as long as you accept some block or some, state of the chain as being acceptable, you no longer have an external dependency on any other factor to keep your time up to, properly synchronized with the rest of the network. You simply have to, I guess, have an alternate mechanism.
We don't need clock synchronization. We only need clocks to run at roughly the same speed. And for this, you don't need an external source for synchronization. You don't need NTP or something to determine the speed of your clock. That only is determined based on the hardware you have.
Okay, but clocks drift. So, and all of our clocks are constantly kind of correcting their drift based upon external sources typically. So that's going to be a factor that's at least going to drive.
Yeah, but
aspect of
as I said, drift is also, at least small drift, like 1%, 10% drift is not a big problem for the protocol. It doesn't accumulate because every time we certify a block, we basically restart our timers collectively. And we only need to, for a few slots at a time, we need to track the time that has elapsed. And then if it's like 2 milliseconds off between nodes, which might be reasonable based on clock drift, then that doesn't throw anything off. It's less than we have as variance in network jitter and so on anyways that we have to account for.
kind of coming off of that question a little bit. I mean, the current system, if we have a legitimate leader L who's processing a block, but then the next leader L+1 jumps the gun, and they're trying to build from the same root, which is what Zan just kind of mentioned. With the current approach and the POH and the leader schedule, L+2 will know how long to wait, because L+1 is going to skip, I'm presuming. Let's presume that everybody votes for L. L+1 will be skipped. And then L+2 is going to have to wait to figure out, okay, which one am I going to build off of? But if for some reason, I guess, will Alpenglow be able to handle that elegantly? That it will just, we know that L1 is going to skip L+1, and then we're going to have a very smooth transition to L+2.
Now I'm not entirely sure if I got what you asked for. Like first, I thought you were asking for the case where I, as the second leader, basically try to take the first leader spot and create a block early.
Yeah, and let's say that, yeah. So let's say that they don't get the votes, so that gets skipped. Those 4 slots from L+1 get skipped because they jump the gun. They're building from the wrong route. But then you've got L+2, which is the next leader after that, who's ready to go. And is there a smooth transition there? If around L+1.
Now I'm not sure. Like if we skip a leader, then the next leader can just produce their block as normal, because there will be skip certificates for every slot of that leader. In some sense, I think it would be exactly the same as if the leader basically crashed or did not produce any blocks.
Okay, all right. So there's still some timing mechanism there. POH is doing that today. And then I guess now we're just going to rely on system clocks instead. So this is what it sounds like.
For the skips, we would use the local timeouts.
Okay.
So for every slot, you would, every node would trigger a local timeout at some point, and if a majority of nodes does this, then they would cast their respective skip votes.
Yeah. Okay. I mean, it's a valid scenario to think through, because we've seen it happen plenty. We've seen it happen where the next leader jumps the gun, and they start to build off of it's not their turn yet. So,
but maybe another point to mention is in Alpenglow you cannot even build a legal block if you're trying to sneak in early. Like if leader L is honest and produces their blocks, and I'm leader L+1, I will never be able to produce a block that anyone will accept that builds off the leader L-1, because all of the blocks of leader L will be accepted and not skipped, and therefore there will not be a skip certificate. And the skip certificate in these slots would be a prerequisite for my slot, for my blocks, which build on the previous leader, to even be valid. Like every honest node would just reject the block.
Yeah, if L is slow, that might cause L+1 to jump the gun. So anyway, we probably don't need to bog down too much. But it's interesting scenarios. Yeah.
Just to
we
interject,
managed to lock back on.
I just want to mention, Kobe was going to do a presentation and had some slides, but unfortunately he cannot get back into the Google Meet. So I think this is the talk at this point, unfortunately, unless Kobe can get back in.
Unfortunately, I don't have the slides that Kobe has. He had some other slides. Maybe I can improvise to some extent if we want to go through that.
Maybe we just schedule it again for next meeting.
Yeah, perhaps. Sorry about that. Did you have slides you want to present, or we could just? Oh, there's Kobe. Great. He should be able to join now. Kobe, are you back? I think he's joined.
Hello, hello. Can I be
Here he
heard?
goes. All right, welcome back. Sorry about that.
That was amazing. I said hi and left. All right, let's see if I can share my screen now. Have you had fun without me? Did Quentin say something?
They were grilling Quentin.
Hmm.
We ended up canceling Alpenglow, so
Okay.
nah.
Okay, share. Does it work finally? No?
Not yet. But everything's moving slow.
I'm not sharing. This Google Meet is really, what is it doing?
Can I ask another quick question while you're getting that going? Time related. Does that mean that like time adjustments are bad? Like if you use an NTP server and it adjusts your clock, is that going to cause a problem? Because it can cause you to suddenly have a very different idea of how long the current slot is taking, or is that not a factor?
I mean, the simplest thing is you could just use the monotonic clock that you have in the system, and then not care about outside time at all.
So I assume that those who implement this will be aware of that and will choose the correct clock mechanism to make sure they don't get bitten by clock adjustments.
Yeah, I think so.
I can see it now. Kobe.
Amazing. Finally. Let's see if it was worth it. It's just a few slides. All right. So yeah, this is Solana Alpenglow, right? Okay, there's these three research guys. One is me, one is another brilliant guy, Quentin here. Hi, Quentin. Another one is Roger. You may have heard of this guy as well. So let me say some stuff. Okay, if you have to go and check your email, I just want 2 sentences first. So my message is Alpenglow destroys the competition, so then we all win, okay? And it's more efficient. So better use of bandwidth, less compute, it's less cost for validators. Okay, why is it so good? So I'll say just some high level general things, and then most of this let's see what you want to talk about. So just quick few slides about general things. One-step consensus, right? So in Alpenglow, you may have heard there's this feature where we might conclude consensus after just one round of voting. Okay, and there's this long line of work. So I just wanted to say it's complicated line of work. There are bugs in the meantime, but Alpenglow is like a cherry on top of this line of work, where we get the best of both. So this one round of voting with 80% of the stake participating, right, concludes consensus. But depending on the stake distribution, it could be that 2 rounds of voting with lower participation might be faster. And in the same execution, even for the same block, these things happen in parallel in Alpenglow. So I just wanted to say, yeah, we get the best of both worlds. And it's like papers, examples of papers in this line of work, which Alpenglow kind of builds on. Okay, that's one thing. Alpenglow is amazingly fast. Yeah, this slide you might have seen. Alpenglow is amazingly fast again. Yeah, I wanted to show you this general structure. This is very general, intuitive overview of what happens in Alpenglow. So leader disseminates blocks. This is not so different from how it is today. So the leader disseminates, erasure codes the block into different pieces, then sends to relays. The relays sends to other nodes, and so on. So this is the purple arrow and the green arrow. Okay, and then there's these 2 rounds of voting. Okay, maybe for now, should I ignore the questions for now? Yeah, let's. This is just like 2 or 3 more slides, and then we'll get to the questions. So, notarization votes, we send them. Then if we have enough, we've already concluded consensus super fast. But in parallel, we start the second round of voting, and for some nodes, seeing the second round of voting from a smaller proportion of the nodes might be faster. And these things happen in parallel, so we conclude as soon as we see the faster path conclude. All right, that's very good. Okay, here I have some slides to base the discussion on if you have any questions. So here we have vote types if you're interested in that, and certificate types. Okay, I also have some more slides to base the discussion on about throughput, but maybe let's leave that for later. Quentin also made some slides, right? So should I leave it to Quentin now? Quentin, you want
yeah,
to show some slides?
I mean, my slides are also mostly discussion slides, so yeah, we can go through them, but we can also go through questions if that's more urgent.
Okay, maybe make the 3 most important remarks you want to make, and then we see what we want to discuss.
Yeah, I could basically read out my overview slide, and then we can see if any of the topics are interesting or if we want to go through questions. So I had some slides about some cool things about Alpenglow for validators, which I wrote down as lower protocol overhead, so less bandwidth used for just consensus protocol related stuff. Then
You're not gonna share slides, or?
I thought I'd just read out these 4 points and then we decide.
Okay. Sorry.
And running out of the box agave will give you full vote rewards. So we will make sure that it's not profitable to tweak around with the voting logic and potentially break consensus just to get a few more bucks on rewards. Then built-in recovery mechanisms for when things do go wrong and many nodes do go down, or we have big network problems like cables are cut or whatever. And we will eventually be able to scale bandwidth arbitrarily across multiple machines. Yeah, these are the main topics I'm prepared to talk about, but otherwise we can have questions, I guess.
Yeah, there are a good number of questions in the chat. I don't know if you want to go through some of those or maybe just discuss the points. I think one thing to point out before we get into turbine and the relayer is that the plan, as far as I'm aware right now, is that any turbine changes will not happen on the initial launch of Alpenglow. So Alpenglow will just be focused on the consensus layer in the V1 version, and then turbine changes will happen after that in separate SIMDs. Yeah, I don't know, Quentin or Kobe, if you want to
Yeah.
answer any of the questions.
Yeah, this
there are
is
some
correct.
questions. There,
And we will also be testing some of the turbine modifications on the unstaked nodes in advance of the rollout for the staked nodes. There are some advantages towards the new algorithm as far as unstaked nodes are concerned, so we will want to leverage those maybe even before we migrate to Alpenglow consensus. And then we will have feature gates in place so we can always switch back to the original algorithm if we encounter any trouble. So, addressing the concerns of like breaking the cluster, we know how to be very careful.
I just read this question about the previous problems with edge cases. I mean, in the consensus as it is right now. And I just wanted to maybe give a little bit different perspective. So I want to say that all things considered, Alpenglow is going to be much simpler. And I think we've put much more, how to put it? We put much more stress on it being correct with respect to all of these edge cases. So I would actually think we have, how to put it? I would be more worried that there would be problems related to consensus with the consensus we have right now, rather than after we switch to Alpenglow. Okay, I think we're significantly reducing the risk of finding new edge cases and problems related to consensus outages.
So if I can just
Isn't
expand
that-
on that. I mean, I have to say, as a person who worked in software development for many, many years, there is a certain hubris that comes with creating something new and believing, oh, we're not going to make the mistakes that someone made before. Our implementation is not going to have a bug that's going to bring down the cluster. And I'm not suggesting that you will have any of those things. I'm only asking, as a validator operator, do everything you can to make sure that you don't do that. Of course, one could say that's what was always done by everybody, but just keep that forefront in your mind. Do no harm. Before you do anything else, I don't care if Alpenglow is faster. I don't want the cluster to go down. That's my major concern. So
Okay.
Yeah, I'll second that. And you guys need to really, really just think about adverse scenarios. And you're assuming a lot of happy path scenarios here. And if you've got a slow leader, then what? What if the leader behind that one is also slow? Then what? Really aggressively try to break it, because literally we've seen since the beginning, we've seen all this crazy shit happen. And so, yeah, we'll, and it's a good thing. I mean, if, consider it a healthy skepticism, just to try to make sure that we've all collectively thought through the edge cases and all the weird shit that will happen, because we know it will.
Yeah.
So, yeah.
To that end, we are working on an emulation of the cluster at scale. So we should be able to emulate a few thousand staked nodes and basically run this completely virtualized with full control over clocks, packet losses, jitters, reordering, any sort of thing we might want to introduce. And basically, if you have a particular nightmare scenario that you are concerned about, please send it our way. Feel free to open an issue on the repo, let us know, and we will make sure that it's in the test suite for the emulation, such that everybody can be fully convinced that, okay, every nightmare scenario engineers at Anza and all of the validators could come up with is accounted for, and we know that we will not fail in like uncontrolled way in that nightmare scenario. So we should be able to emulate everything.
Okay, yeah. And then we'll put it on testnet, and then we'll issue some bug bounties, and then we'll see what everybody forgot about. So, yeah.
Well, we may very well
Obviously.
have some test clusters as well, right?
Yeah.
But
It's
bottom line is
anyway.
that-
Yeah, don't take it as being like negative or anything, because I am really excited about what you guys are building. But don't deceive yourselves into thinking this is easy, because it's not. So, but it's going to be a lot of fun. I'll say that. Yeah.
We have no intention to think that this is easy, which is why we are taking the whole idea of emulating scenarios we cannot expect to happen in real cluster, kind of on demand, on purpose, such that we can account for things that should never be possible.
Mhm.
There's a question in chat I want to get to real quick. So Chris was asking about two voting paths, one that require 80% of stake, and another potentially faster path, essentially the 60% of stake. Could any one of you talk about how those two systems work, how the 80% or 60% works?
Okay, how about I illustrate what I mean with the 60 and 80% with an example? So let's imagine 60% of the stake is concentrated in one town, just a single town. Let's say 60% of the stake is in New York. And the other 40% of the stake is in Tokyo. Okay, what would happen then? If some node in New York is the leader, and it disseminates the block, and everyone in New York gets the block almost immediately, then everyone in New York votes almost immediately. But then to get this 20% of votes from Tokyo, it takes some time. Meanwhile, the 60% of nodes in New York, they already see like 60% of the stake voted with the notarization votes. And then they're like, okay, this is the notarization step. Now I'm also doing the second finalization step. So again, the 60% votes, yeah, I want this block in. So then these two rounds, just among the New Yorkers, they would be super fast, right? So this depends really on the distribution of stake. Like if the stake is very uniformly distributed around the globe, then just one round of voting where you distribute your block, everyone would get the block sort of at the same time, then everyone would vote sort of at the same time. And at some point when we get the votes, almost immediately after the first vote, we would get 80% of the votes and we would finalize. Then two rounds would be 2 times longer, essentially, than one round. So depending on the stake distribution, okay, this is so funny because it can be for a different node in the same execution, even for the same block, okay, a different node will finalize faster with one round of 80%, or some different node will finalize faster with 2 rounds of 60%. So we get the best of both. Did that make any sense? Did that answer the question?
Yeah, hi, this is Chris. So it sounds like if you get 2 rounds of voting on 60% of stake, that path is chosen. I mean, if the 2 rounds of 60% voting happen before 1 round of 80% voting.
Mm-hmm.
Is that essentially how it works?
These things happen in parallel, right? So
right.
You finalize as soon as you see 80% of yes votes, then you finalize. Or if you see the second round of yes votes from 60%, which happens when they so you send your second round vote if you see 60% voting yes already. Okay.
Right.
So you're looking for both. As soon as you see the first of them, you finalize.
I see. And the expectation is that the case of the 60% voting would happen most likely if these validators are close to each other. Close being very subjective, obviously.
Yes. So if there's a big difference between, so the latency, like your latency to like 80% of the stake is much, much higher than your latency to 60% of the stake, then like you having 2 voting rounds with 60% of the stake could be faster.
And then is there any additional benefit to the validators who voted for the 2 rounds of 60% over the validators that say didn't? I guess what I'm getting around to is this encouraging centralization? Is this encouraging everybody to cluster around the same cities more so than we already do?
Yeah, so actually it's the opposite. What I mean by that is there's going to be a benefit to centralize in any consensus protocol, but with what we're doing with the 60 and 80%, we're making it faster when the stake is spread out. So if you're like some distant node, usually for you, seeing the 80% of first round votes would be faster than seeing 2 rounds of votes from 60%. So I mean, this mechanism, okay, the point is this mechanism makes it better for these distant nodes, and it makes the difference smaller between like a scenario where the stake is centralized and where the stake is spread around the globe.
Okay, I understand the intention. I don't quite understand how we get there yet, but I'll do some more research on my own and come back with some other questions. Thanks.
Howard, do you have a question?
Yeah, thanks for coming on, sharing all this. It's amazing. I was wondering if there's any more thinking about the multiple concurrent leaders, considering, Anza's making steady and quick progress toward that from one direction, and Alpenglow is coming in at a seemingly similar but parallel time, and how that impacts the execution layer. It sounds like, from my reading, that the new consensus helps really remove one blocker, but there's still execution layer things to consider.
Yeah, I would say multiple concurrent leaders is still, as you say, right? There are still things to be figured out about it. Like, it's sort of research in progress. So yeah, this may take some time. Well, Alpenglow is, yeah, we know what we want to do and how to do it. It's figured out. I mean.
Cool. So it sounds like maybe the consensus is so much better that could get put in soon along the parallel paths that Alexander was talking about, and then we upgrade that part before other novel mechanisms are put in, something like that.
You're saying that we would do Alpenglow before we do multiple concurrent leaders. I think this is.
I don't know. Is that what you're saying? I don't know.
I think it's.
I am asking
think
that. Yes.
Yes. I think the chance that we do multiple concurrent leaders faster than Alpenglow are slim to non-existent.
Yeah, there's discussion in the chat about slashing. I don't know if anyone wants to talk about that specifically, but essentially what events might be slashable in the new protocol.
Yeah, it's mostly combinations of votes that you should never do. Like, any honest node would ever, for example, cast either skip vote or some notarization vote, and if you cast both, then you can be slashed. And the node will never cast an honest node will never cast a finalization vote and a skip vote, for example. And then if you cast both, then you can be slashed. Like, any of these combinations that are not that an honest node would never send can be slashable offenses. And then, of course, the same things as before, like sending 2 different blocks as the leader. Sending shreds of 2 different blocks can still be slashed.
All right, we're close to time. Any last questions before we wrap it up?
No, for me, I mean, just to say this is exciting, guys. So we're just trying to help you think through maybe some of the things that haven't been thought through yet. But it's all exciting work that you're doing. I love to see it.
Yeah, let's see who's Zan, then Andy to close it out.
So with the current consensus model, we had a long time where there was no specific reward for the speed of voting, and recently we've introduced changes that allow validators to earn more if they vote sort of more faster, with, of course, the same accuracy as they had before. And that has had a lot of interesting effects. I believe that one of them is that it has increased the speed of Solana, but that's probably up for interpretation. Do you have a similar concept in your consensus model in terms of how validators are rewarded? Are we going back to the state where validators can benefit from waiting and holding out on their votes to try to see what the network is collating on before deciding to vote, or is there something already built in to prevent that?
Yeah, this is an excellent question because, yeah, the whole time sensitive rewards, right? They stem from the fact that in Tower, you might have a reason to hold your vote and see what's going to be like profitable to vote for, right? So this is a little bit of a perverse incentive. And so the point is, we will definitely not have something like that in Alpenglow where deviating from the protocol would net you more rewards. So you wouldn't have a reason to wait, and then you wouldn't have a reason to go after like more and more incentivizing that, okay, now you don't want the validators to deviate from the protocol and so on. So this was one problematic thing in Tower that will be solved in Alpenglow, where you stick to the protocol, you get the rewards.
But to be clear, there was no deviation from the protocol in the current consensus model. There was only delaying your vote to survey the network and see how other validators are voting before committing. And the only way you can say that you will never, you'll always just vote is you never have a choice to make about two different scenarios to vote on. And if you're saying those designed is you never have a choice about what you would vote on, and thus never have the advantage for waiting to gather information, then that's an interesting claim.
So I have to disagree, because definitely delaying your vote is deviating from the protocol in my book. And I mean, this is a problem for the protocol. If everyone does this, like, it wouldn't work, right?
But I mean, it's indistinguishable from network latencies that just could happen because routers are slow or whatever. I mean, that so it's
yes.
You can call it a deviation, but it's just the fact of how networks work.
No, everything could happen, right? So you are right in the sense of, okay, if things are delayed, Alpenglow is partially synchronous, meaning whatever you delay or packet loss or whatever, it's not going to break the protocol. It will delay it. But then if you do it intentionally, in my book, that's a deviation, right? Even though the conditions would permit the protocol to be faster, like you're delaying your vote, that's not good.
But the point is, since that's indistinguishable from a natural delay that might occur outside the validator's control, how do you distinguish those cases, and how do you ensure that validators are incentivized to not delay, and hide their delays as, normal latencies?
You want to go ahead, Quentin?
I just wanted to make the point that you do break something by delaying. You break the core guarantee of liveness, that if the network is good, then the protocol makes progress. And if you have honest nodes with nodes which you call honest, but they delay messages arbitrarily, then you might no longer have liveness. Like, you might not make progress even though the network is good.
That's fine, but like I said, that can happen under normal circumstances too. So the question is, how do you, incentivize validators to not delay any more than necessary, and claim that, that was just because my router was slow or what?
Yeah, I just wanted to make the point that Tower is quite peculiar in how it gives you a reason that you could wait and then potentially gain from that. So the point is that in Alpenglow, there is no scenario in which you have a reason to wait. And I guess that's enough, right? Because why would you wait if there is no scenario, no execution, no point in ever waiting? Like, if the protocol tells you to vote now, you vote now.
I guess, like I said, that assumes that there's never two conflicting events that you could choose which to vote on, and thus wait to see which one the cluster sort of like congeals on before voting.
That does not necessarily assume that. I mean, the consensus outcome might be undecided yet, but incentives might be structured such that irrespectively of what you vote for, you're gonna receive the reward, right?
I don't know. I'm sorry, I haven't read as much detail as I should, so I'll table this question until I have a more solid grounds for the question.
No, but I mean, definitely you made a very good point, right? That this incentive to wait, right? This is a problem. I just wanted to say this problem is no more.
All right, we're at time. I want to thank the research team, Kobe, Quentin, and Roger, who's not here, but also part of the research team for working on Alpenglow and for answering questions. And thank you to Brian as well for joining and introducing himself. Next validator call will be the community call in 2 weeks. Yeah, anything to add there, Chris?
Nope, but yeah, we skipped last month because of Accelerate, but we'll have it going again this month.
All right, great. Thank you all. See you all next time.
Thanks, guys.
Thanks
Have a
for
good
the
one.
call.
Thanks. Bye.
Thank you, Google Meet.
Bye, Garrett.
All right.